Design and structure of multi-purpose agricultural robot. Abstract. This paper presents a project on agricultural multipurpose robot aimed at designing, implementing, and testing an autonomous multipurpose vehicle with efficiency and economic operations for tilling, sowing seeds, spraying fertilizers, and sprinkling water simultaneously. It operates on solar power and is fully automated and can be used in arid and semi-arid lands with ease by single individual. This vehicle moves through the crop lines and performs tasks, thus reducing requirement of manual intervention. Keywords: autonomous robot, agricultural robot, agribot, mechanical implant for agriculture. Introduction: agriculture is mainstay of many nations across the globe. There are multiple interventions by many scholars to utilize technology and mechanical intervention into agriculture. In the early 1920s itself there were attempts to implement robotics to help improve agriculture. These were primitive models that required use of cable connection to operate the machine. Revolutionary attempts in the field of applying robots to agriculture continued to develop, especially after 1980s, as technological advancement in the field of computer science and engineering made machine vision, MV, guidance possible. Machine vision is nothing but integration of many technologies, software, hardware products, systems engineering, applied mechanical engineering actions, methods, and expertise. It is integration of these technological advancements to resolve real-world issues and problems on hand. Our design and structure of agricultural robot is one such attempt to help the farmers reap the benefits of technological advancement and to get benefits. An agricultural robot is a robot deployed for agricultural purposes. It utilizes MV applications to identify required tasks assigned and shall do as per given schema to achieve results. Robots are mainly applied in the field of agriculture in weed control, seeding, and harvesting. Soil analysis and environmental monitoring are other areas where robotics and AI are helping the farmers. In the coming years there is an expectation of exponentially increased market for robotics in agriculture applications that would touch over $10 billion. What is our agricultural robot all about? Having mentioned that the market for robotics is set to increase many-fold in the coming years, and the limitation of current versions of applying robots in mostly harvesting stage and weed control, it is important to showcase a design and a model of our robot that has multipurpose usage, namely in tilling, seeding, closing the pits and leveling, spraying fertilizers and also sprinkling water simultaneously. Thus, it helps the farmers in increasing their productivity, reduce cost of operations, lower maintenance, and increase their overall development. Many of the versions that are available in market or are being developed elsewhere globally have one limitation, that they all are making robots to work in predefined way of work. So, specific tasks that are often repeatable and can be programmed were only being addressed. Most of these machines require either electricity or battery to operate. Our robot is designed solely to minimize the labor of farmers in addition to increasing the speed and accuracy of the work. It performs the elementary functions involved in farming, i.e. plowing the field, sowing of seeds and covering the seeds with soil, spray fertilizer, sprinkle water et al. The robot is autonomous and provides the facility for optional switching of the plowing system when required. This is adjustable manually to suit the land conditions. It operates on solar power and can be handled by single individual. Design of the agricultural robot. Following inputs would summarize what we intend to achieve by developing this robot. 1. This project is a 4-in-1 robot which is designed to complete simultaneous tasks automatically. 2. The basic frame of the robot is made of mild steel of 25 mm thickness with the dimensions of 510 x 450 x 360 mm accordingly. This forms the basic frame. 3. Plows are made up of brass alloy to perform digging, with the length of 50 mm and thickness of 20 mm. The steel flaps are used to cover the soil pits once the seeds are dropped into the soil. 4. Seed container is made of stainless steel of 5 mm thickness as shown in the figure. The water and pesticide/fertilizer container are placed in the robot as represented in the model diagram. 5. Wheel diameter is 56 mm. 6. Solar panel is placed at a height of 80 mm at an inclination of 15 degrees. The solar panel is placed in such a way that the robot can collect the required energy for its functioning directly from sunlight. Fig. 3, Functional Prototype of Agricultural Robot. Technical details of Agricultural Robot Prototype Model, Dimensions, 510 x 230 x 210 mm weight, 6 kg water tank capacity, 1.5 liters fertilizer tank capacity, 1 liter frame material, mild steel thickness, 15 mm solar panel, polycrystalline, type, power 10 watts voltage, 12 V current 0.8 amps efficiency rate 15% motor, DC motor, direct current, speed 30 rpm, high turn, current 150 mA components, solenoid coil voltage, 12 V, microcontroller ATMGA 328 controller type, self-programmable memory 32 KB power. Consumed 0.2 mA. Multipurpose agricultural robot is definitely useful to all the farming community across globe, as it would not only reduce the manpower needed to complete the tasks but also increases the efficiency of farmers. See Table 1 Usage Efficiencies for details. Table 1 Comparison of usage efficiencies across factors. Factors: manual tractor, agricultural robot. Manpower: high, moderate, less. Time required: high, moderate, less. Plowing/tilling: manual, automatic. Seeding: manual, automatic. Watering: manual, automatic. Fertilizer/pesticide: manual, automatic. Required energy: high, less. Wastage: high, less. Unique/salient features: while there are many agricultural implants that are manufactured and utilize robotics and AI, our robot is innovative and unique in the following ways. Its design is such that the entire operation can be carried by single individual and requires less human intervention. All 4 functionalities mentioned elsewhere, such as digging, sowing, closing, and sprinkling of water and fertilizer, are done simultaneously. Unhindered operation of this machine in semi-arid and arid regions is easier, as the movement is not interrupted by wet and muddy soil. Our agricultural robot utilized solar energy and generates power that is stored in uniquely placed battery, thereby can be used in any place without depending on electricity. Cost-benefit analysis of use of this robot. For the purpose of analysis, let us see how the cost-benefit works for farmers' favor by using our agricultural robot. Assumptions: for working out costs, following assumptions were in place. We are taking 1 acre, 40 guntas, where 1 gunta equals 1028 SFT, arid or semi-arid land. Crops are either red gram or corn. Duration of crop: 4 months. Rates assumed are in INR, prevalent in Karnataka. For male 500 per day and female 300 per day. Normally it takes 2 people, 1 male and 1 female, for 2 days to till the land and plant the seeds. It takes additional 1 day to spray fertilizer and water the land. Let's assume that we might require 11 days of labor for maintenance of land throughout the crop time, i.e., roughly 4 months. Also, for weed removal and sprinkling water it might take additional 4 days. Thus, it's in all 18 days of labor for 2 people, male and female. Thus, cost for performing all the activities mentioned above for acre of land comes to INR 14,400 for 1 crop. On the contrary, using this machine agricultural robot to complete each of the tasks for every acre of land, cost comes down significantly, as it can be operated by 1 person alone, who is actually hired to not only do these tasks but also oversee its total responsibility for the crop. Thus, operational expenses for this machine can be said to be minimal. As the robot operates on solar power, electricity expenses too aren't required. Additionally, weeding can be done intermittently in the land for maintenance of the crop. This too is easier, as the robot can be operated by the same single individual without much effort. Weight of the robot 2 is roughly 6 kgs and can easily be transported and installed. Conspectus and the way forward. To sum it up, solar-powered agricultural robot has been designed and prototype is developed for performing agricultural tasks. It is designed to multitask and helps farmers in improving efficiencies, reduce utilization of manpower and costs. This small-sized vehicle, as mentioned above, weighs around 6 to 8 kgs and is easily moved around by single person. To improve the efficiency in the agricultural sector, there is a need of the mechanical control system. This can be achieved by the robots, which can work faster with more productivity. This maneuverability and multitasking is the main advantage of our agricultural robot, as it performs tilling, laying seeds, spraying fertilizers, sprinkling water, all simultaneously, that too utilizing solar energy. It can also help in removing weeds and do additional tasks. How we program with different tools.